In this video here, we are exploring some nuance. We're exploring our exponent laws a little bit further. We'll be looking at how a fraction as a base and how negatives in the base or around the base affect our power in general. The prerequisite skills we're relying on. You need to make sure, if you're in this video, you need to make sure you are a master of multiplication of powers. You need to make sure you're a master of division of powers, and you need to make sure you're a master of a power rule. This video is suitable for anyone who's looking to explore their exponent laws a little bit further. It is suitable if sometimes you lose track of your negatives, if sometimes you're not sure why a negative base turns into a positive power, or why other times a negative base turns into a negative power. This is the spot for you. Now, our exponent laws. Let's take a look. 3 over 2 to the exponent 3. When we're working here, first of all, we're going to be careful. And second of all, we're going to follow one golden rule almost the entire way throughout this lesson. And that golden rule is whatever is right in front of the exponent is the base. So in this case, our exponent is 3. Whatever's right in front of that exponent, in this case, is a set of brackets. And that means absolutely every single thing inside these brackets is the base. And if every single thing inside these brackets is the base, then what we can do is we can apply this exponent to every single thing inside of these brackets. That is, we're working with 3 to the exponent 3 over 2 to the exponent 3. We know how to work with this, nice and easy. Now we have a power. Could we use our division of powers rule? No, absolutely not. These have 2 different bases. You need to make sure you're nice and careful. But now you know how to handle it if we have a fraction inside our base. Over here, same thing. We have ourselves a fraction. This time our fraction has some exponents, so we'll be a little bit careful. But we have a fraction inside our base. How do we know it's inside our base? Because immediately, right before this 4 are my brackets. And if I have my brackets before, then absolutely every single thing inside our base, every single thing inside our brackets is going to be a part of the base. So if that's the case, this 4 must apply to the a to the exponent 2. It must apply to the b to the exponent 5. How does it apply? Well, I'm glad you asked. What we're working with here is a squared all to the exponent 4 divided by b to the exponent 5 all to the exponent 4. Now, if that's the case, you know how to handle something like this. All we're working with is a power of a power in the numerator, power of a power in the denominator. We're multiplying our powers here because you're a master of this. We're working with a to the power of 8, all divided by b to the power of 20. There you are. We cannot take this any further, even though there's division, because, again, the bases are different. All right? Nice work. Next, we're working with negative x to the exponent 4. Which is different than what we'll be working with next, which is negative x to the exponent 4. Now we're working with negative x to the exponent 4. Nice and easy. What is immediately in front of that 4? It's our brackets again, meaning absolutely every single thing inside is to the exponent 4. What does the exponent 4 really mean? Well, we're just multiplying the base times itself 4 times. So this is like negative x times negative x times negative x times negative x. And if that's the case, really what I have is a negative times a negative, oh, that's a positive. A negative times a negative, oh, that's a positive. And I end up with a positive times a positive. So really what I'm working with at the end of the day is a positive value. And that positive value, what else is included other than just my negatives here? So I'm going to have a positive. What else is included other than all of my negatives? Oh, all of my x's. How many x's are there being multiplied together? 4 of them. So this is x to the power of 4. So that means that negative x to the power of 4 is equal to x to the power of 4 when it's set up like this. Now instead of, and I realize this is going to be tough on your math brain to hear, so I'm hoping that you're following along the algebra that I'm looking at as I say these things, instead of negative x to the exponent 4, we're going to work with negative x to the exponent 4, but there's a difference. What is my base here? Oh, this time the only thing immediately in front of my exponent 4 is the x. The negative is not. The negative is not inside. There are no brackets to attach these together this time. So this time the only thing that's being multiplied by itself 4 times is the x. So if I were to write this out, if I were to expand this, I'd be working with negative, because I bring that down as I work forward. Negative x times x times x times x. Where in this case, our negative sign only shows up once. If it only shows up once, there is not another negative sign to cancel it out. If there's nothing to cancel it out, nice and easy, I'm working with negative x to the power of 4. So that means these two things are true. Ready? Negative x to the exponent 4 is equal to x to the exponent 4. That's true. You know what else is true? Negative x to the exponent 4 is equal to negative x to the exponent 4. All right, you cannot hear the difference when they're said out loud, but those brackets that are involved really change the value of what we're working with. In one case, it's positive. In the other case, it's negative. Now I'd like to go through some common traps. I've only written out one of them. I'll discuss the others as I go through. I'm hoping this will be effective as we work. Now, the common trap right here. Right away, there's been a mistake, frankly, just with our exponent laws, right? You need to make sure you're a master of multiplication of powers. If we're multiplying our powers, there's a hidden exponent on this numerator. That is 5 to the exponent 1. And if I'm working here, what is the base of my power right here? Oh, it's the whole piece because I have my brackets. It's 5 to the exponent 1 over 6 to the exponent 3. If I am applying my power of a power rule here, then I will need to make sure I'm multiplying my exponents, and then I'm multiplying my exponents. So instead of a 35 in my numerator, I'll be multiplying the 7 times the 1. I'll be leaving the base the same. I'm working with 1 to the power of 7 times 1. That's 7. Sorry, 5 to the power to the exponent. I'll be working with 5 to the exponent 7 times 1. That's 7. Fantastic. In my denominator, again, this 7 applies. So I'm working with 6 to the exponent 21. That was done correctly. Nice job, us. Next, another trap you might fall into. We're working here. We have a base negative 3. We have a 5. You might be tempted to write, oh, this is just negative 3 to the exponent negative 5. That's not true. There's only one negative sign. All right, there's your first trap. Second trap, you might say, well, you know what? I've seen a question like this before. When I had a question like this before, I had a negative base, I had an exponent, and I had my brackets. Those are some similarities between these problems right here. Now, if those similarities are true, then maybe we can just take the same shortcut. Last time, all we did, we ended up getting rid of our negative, so this time we'll get rid of our negative. We're working with 3 to the exponent 5. Does that work this time? Let's break it down. Let's take a look. I'll use another color here. Let's take a look. We're working with negative 3 to the exponent 5. That is negative 3 times itself 5 times. And here, let's track our negatives. Okay, I have 2 negatives. They cancel to make a positive. I have 2 negatives here. They cancel to make a positive. And this has no other negative to cancel with because there were only 5 negatives I was working with. So in this case, my exponent 5, because it's an odd number, there are only an odd number of negatives to work with, this negative will carry through. Negative 3 to the exponent 5 is just negative 3 to the exponent 5 with no brackets. Right here, negative b to the exponent 5, nice and easy. There are no brackets. There's no way to simplify this. We're just working with negative b to the exponent 5. Just as we did before. Remember, we expanded it. We tried. There was no way to cancel out because there was only one negative sign to begin with because the base we're working with is not negative b. The base we're working with is just b. If you followed along, I encourage you, pause the video here. Try out question D. Expand this. Double check to see if our negative survives, and then see where it goes. Absolutely, our negative survives because I have 5 negatives to work with. The negative is a part of my base. I have 5 of them to work with. That's an odd number. So some will cancel out, but I will still be remaining with a single negative here. If you're not sure what I mean, expand it as we did before, and see what happens. If you followed along, I'm hoping you feel a little bit more comfortable with fractions and negatives involved in or around your base. Nice work.